Shade the region between y is equal to sine x and the x-axis and find its area. So step 1, sketch the function. Okay, so y x, this is 0 by 2 pi. The area that we are interested in is this one. So I'll label this A and B. So let me start with the area of A. Now, before I even start working out the areas of A and B, we can see that the area of A and the area of B are identical. So area of A is equals to the area of B. So what I'll basically do here is I'll work out the area of A, work out the area of A, and then to work out the total area, I'll just multiply that by 2. So the area of A will be the integral from pi to 0 of sine x in the respect to x, which will be negative cos x by 0, give us negative cos pi minus into bracket negative cos 0. Plugging in the limits, you end up with a negative 1 plus 1, which is 2. So the total area, which means A plus B, will be just 2 plus 2, which is 4. If you wanted to work out this question on your calculator, all that you have to do is go to alpha window, and then lower limit is 0, upper limit is 2 pi. And then you have sine x. Now remember, don't forget absolute value. So math, because you have, so absolute value sine x, and with respect to x, and you should be able to end up with the same answer. So if you have a question like this in a calculator paper, you know what to do. Non-calculator paper, you know what to do. Okay, number 4. Shade the region enclosed by the curve and find its area. Now, of course, step 1 is to sketch, but before we sketch, by inspecting this function here, we need to know what the period of this function is before we can sketch it. Now, the period of this function will be pi over the coefficient of x, which is a half. So the period of this function will be 2 pi. So to sketch it, you know how the tangent function looks like. So, but the fact that you know that, the period of this function is 2 pi, you can keep that in mind as you sketch it. Okay. Since the period of this function is 2 pi, that means that will be pi. And that will be negative pi as well. Okay, to have a period of 2 pi. Now the boundaries, y is equals to 0, which is the x-axis, and then we have between x is equals to negative a half and x is equals to pi over 3. So which means I'll have, so here I'll have negative pi over 2, negative pi over 3, and this is the area that I'm looking for. Obviously, you can see that it will be negative, so we'll apply our tricks when we work out the area of that. So area will be equal to negative integral from negative pi over 2 to negative pi over 3 of 4 tan x over 2, and here integrating with respect to x. What I'll do is I'll rewrite this. You know that from trigonometry, we can write an x as sine over cosine, you know. So negative pi over 3. So I'll actually write the 4 outside the bracket. That way I can just focus on whatever is happening here. So sine x over 2 over cosine x over 2 with respect to x. I'll have more space here. This will give me, okay, we may have to use some substitution here. So let u be equal to cos x over 2. So which means du over dx will be equal to negative, remember I'm differentiating here, so a half sine x over 2, which means that just get more space if it's possible. Good. So what I'll end up here is means that dx will be equal to du over negative a half sine x over 2. Anyway, since we have a new variable, let's change the limits. So at x is equal to negative pi over 2, u will be equal to cosine of negative pi over 2 divided by 2. Let's use this bracket. So this is same as cosine negative pi over 4, which is same as cos negative 45 for those of you who are comfortable working with the degrees. Now, we know from this little triangle, right angle triangle, that, and in the third quadrant, cosine is positive. So what we'll end up with here is 1 over root 2. And then at x is equal to negative pi over 3, u will be equal to cosine of negative pi over 3 divided by 2, which will be equal to cosine of negative pi over 6, which is same as cosine negative 30. Now, cosine of negative 30, you can use the special triangles to figure that out. So 2, 1 over 3, this is 30. So cosine 30 will be negative 30. Again, that's on the fourth quadrant, not the third quadrant, fourth quadrant. That will be root 3 over 2. So putting these results together, we shall end up with integral. Remember I had negative 4 integral. My new limits are from 1 over root 2 to root 3 over 2. Because, you know, at x, when x was equal, just going back up, at x is equals to negative pi over 2, I ended up with 1 over root 2. At x is equals to negative pi over 3, I ended up with that. So those are my new limits. And then plug in whatever I had. So sine x over 2 over u. Remember the substitution. Dx is du over negative a half sine x over 2. What happens here is these two guys cancel. So my integral will be negative 4. Actually, negative 4 divided by negative a half, that will be positive 8. So I'll change this to 8. Integral from 1 over root 2, root 3 over 2, 1 over u, du, which will be equal to 8 ln u, absolute value of u, root 3 over 2, 1 over root 2, which will give me 8 ln root 3 over 2. Of course, the absolute value of root 3 over 2 is just root 3 over 2 minus ln 1 over root 2. Now, applying laws of logarithms, this is equal to 8 ln root 3 over 2 divided by 1 over root 2. This will be equal to 8 ln root 6 over 2.